Alright, let's get right into it. Number 10. In 1967, American satellites built to detect secret nuclear tests instead recorded explosions in deep space so powerful that scientists spent 6 years too stunned and too classified to tell anyone. The United States Vela satellites, launched to monitor the 1963 Nuclear Test Ban Treaty, began detecting brief, intense flashes of gamma radiation coming from deep space rather than Earth, starting in 1967. Physicist Ray Klebsiedel at Los Alamos National Laboratory led the team that finally published the declassified findings in the Astrophysical Journal in 1973, revealing the existence of gamma-ray bursts. A single gamma-ray burst can release more energy in 10 seconds than our sun will produce across its entire 10 billion-year lifetime. In 2004, physicists Adrian Malott and Brian Thomas published research in the International Journal of Astrobiology, proposing that a gamma-ray burst originating within a few thousand light-years of Earth may have triggered the Ordovician extinction roughly 445 million years ago, stripping away the ozone layer and killing an estimated 85% of all marine species. A black hole, at least, announces itself and stays where it is. A gamma-ray burst can be aimed directly at Earth from a dying star we have never even catalogued, and we would receive no warning before the light itself arrived and began tearing apart our atmosphere. Number 9. Physicists at one of the world's most advanced particle accelerators once had to formally investigate the possibility that their own experiment could create a substance capable of converting the entire planet into something else within seconds. In 1984, physicist Edward Witten at Princeton, building on earlier work by physicist Arnold Bodmer in 1971, proposed that a theoretical form of matter called strange quark matter could be more stable than ordinary atomic matter. If even a microscopic fragment of this material, called a strangelet, ever came into contact with ordinary matter, it could theoretically trigger a chain reaction, converting everything it touches into more strange matter. Before Brookhaven National Laboratory activated its relativistic heavy ion collider in 2000, physicist Robert Jaffe led an official safety review specifically examining whether the collisions could accidentally produce a strangelet capable of converting the entire Earth into a dense, dead sphere of strange matter within seconds, a scenario the review ultimately deemed statistically negligible but not notably impossible. No strangelet has ever been confirmed to exist. But if one does, and if it ever reaches a planet, there is no explosion, no warning, and no way to stop it. The world would simply stop being made of what it is currently made of. Number 8. In 2004, a single crack in the surface of a dead star released more energy in 1/10 of a second than the sun produces in 100,000 years, and it happened close enough to physically alter Earth's atmosphere from across the galaxy. Physicists Robert Duncan and Christopher Thompson at the University of Texas at Austin theorized magnetars in 1992, neutron stars with magnetic fields up to a quadrillion times stronger than Earth's. On December 27, 2004, the Magnetar SGR 1806-220, roughly 50,000 light-years away, released a giant flare so powerful it saturated gamma-ray detectors on satellites across the solar system and measurably ionized Earth's upper atmosphere. Researchers, including Brian Gaensler, have calculated that an identical event occurring within just 10 light-years of Earth could strip away enough of our ozone layer to trigger a mass extinction, all from a single fracture in a star's crust lasting a fraction of a second. Unlike a black hole, which pulls objects toward it slowly and predictably across enormous distances, a magnetar's giant flare requires no proximity, no collision, and no advanced signature. It simply cracks, and the destruction arrives at the speed of light with absolutely no warning beforehand. Number 7. Astronomers now believe hundreds of millions of black holes are drifting silently through our own galaxy, completely invisible, and in 2022, one was finally caught only because it happened to pass in front of a distant star. Because isolated black holes emit no light and pull in no visible matter, they are essentially undetectable using any conventional telescope. In 2022, astronomer Kailash Sahu at the Space Telescope Science Institute, using 6 years of data from the Hubble Space Telescope, confirmed the first direct mass measurement of a completely isolated rogue black hole, detected only through gravitational microlensing, the brief bending and brightening of a background star's light as the invisible object passed in front of it. Sahu's team calculated the black hole possessed roughly 7 times the mass of our sun and was drifting through space at over 100,000 miles per hour, with no visible companion star, no accretion disk, and no way to have been detected through any other method. Based on the frequency of similar microlensing events, astronomers estimate our galaxy alone may contain 100 million stellar mass black holes wandering in total silence and darkness. Unlike a supermassive black hole sitting predictably at the center of a galaxy, these objects could, statistically, be far closer to our solar system than anyone has ever confirmed, and we would have no way of knowing until one passed directly in front of a star we happen to be watching. Number 6. Some galaxies fire a beam of radiation more concentrated than a laser directly out of their core, and in 2017, scientists confirmed one of these beams is currently pointed almost exactly at Earth. A blazar is a specific type of galaxy whose central supermassive black hole fires a jet of particles accelerated to nearly the speed of light, and by pure geometric coincidence, some of these jets happen to be aimed almost directly at our solar system. In September 2017, the IceCube Neutrino Observatory, buried in Antarctic ice, detected a high-energy neutrino traced directly back to a blazar designated TXS 05A6+056, roughly 4 billion light-years away, confirmed through follow-up observations published in the journal Science in 2018 by an international collaboration of over 100 researchers. The confirmation marked the first time scientists directly linked a specific identifiable object in space to a source of extreme cosmic radiation reaching Earth. Blazars are not rare. Astronomers have cataloged thousands of them across the sky. Most are harmlessly aimed elsewhere, but the discovery confirmed, for the first time with direct evidence, that some of these relativistic jets, streams of radiation and particles powerful enough to be detected across billions of light-years, are in fact currently aimed directly at us, and there is no mechanism by which that aim could ever be adjusted or avoided. Number 5. Supermassive black holes do not simply pull objects toward them. Astronomers have directly observed them ripping entire stars apart into glowing streamers of gas that are then partially devoured, in an event visible from across the universe. In 2014, the All-Sky Automated Survey for Supernovae detected an object designated ASAS N14Li, roughly 290 million light-years away, which astronomer John Miller at the University of Michigan confirmed in a 2015 paper published in Nature was a tidal disruption event, a star that had wandered too close to a supermassive black hole and been stretched apart by tidal forces so extreme that its own structural integrity failed entirely, spilling its material into a glowing ring around the black hole. Unlike being pulled into a black hole personally, which would end in a single, relatively swift crossing of the event horizon, a tidal disruption event stretches its victim across enormous distances first, elongating the star into a stream of debris before any of it is actually consumed, a process that can take months to fully play out and remains observable through telescopes the entire time. Astronomers estimate events like this occur in any given galaxy roughly once every 10,000 to 100,000 years, meaning it has almost certainly happened before in our own galaxy's history, and will happen again to some future star in a process visible to any civilization watching from the correct distance and angle. Number 4. Physicists have calculated that as dark energy continues accelerating the universe's expansion, we are losing the ability to ever detect proof that the Big Bang happened, and one day, every trace of it will be permanently gone. In 2007, physicists Lawrence Krauss and Robert Scherer published a paper in the journal General Relativity and Gravitation titled The Return of a Static Universe and the End of Cosmology, demonstrating that the accelerating expansion of the universe, confirmed by the 1998 supernova observations that won the 2011 Nobel Prize in Physics, is steadily pushing distant galaxies beyond our observable horizon permanently. Krauss and Scherer calculated that in roughly 100 billion years, every galaxy outside our own local group will have been pushed away faster than light can ever reach us again, and the cosmic microwave background, the primary evidence confirming the Big Bang occurred at all, will have stretched and faded into complete undetectability. Any civilization existing that far in the future will look at the sky and see only their own isolated galaxy, surrounded by absolute emptiness, with no observational evidence whatsoever that a Big Bang or any other galaxy had ever existed. It is not destruction. It is something arguably worse, the slow, silent, irreversible erasure of the evidence that anything beyond one's own galaxy was ever real. Number 3. Some physicists believe the same dark energy currently holding galaxies together in slow, gentle expansion could instead be a form of energy that grows stronger over time, eventually tearing apart every galaxy, star, planet, and atom in the universe simultaneously. In 2003, physicists Robert Caldwell, Mark Chemiankowski, and Nevin Weinberg published a paper in Physical Review Letters titled Phantom Energy, describing a scenario scenario in which dark energy's repulsive strength does not remain constant, but instead increases without limit as the universe expands, a fate they named the Big Rip. Under this model, roughly 22 billion years from now, the accelerating expansion would become strong enough to first tear galaxies apart, then rip solar systems away from their stars, then shred planets themselves, and in the model's final moments, roughly 10 to the negative 19th seconds before the end, overcome even the nuclear forces holding individual atoms together. Current observational data from missions studying dark energy has not confirmed phantom energy exists, and the standard cosmological model remains the leading explanation. But if Caldwell's model is correct, there is no black hole anywhere capable of matching an ending in which every single piece of matter in existence, everywhere, all at once, is torn apart down to its most fundamental components. Number 2. Long before the universe could ever be ripped apart, physicists calculate it is instead slowly running out of usable energy entirely, heading toward an ending with no explosion, no collision, and no event of any kind, only an eternity of absolute, unchanging cold. In 1852, physicist William Thomson, later known as Lord Kelvin, published a paper describing the universal tendency of energy to dissipate, laying the foundation for what became known as the heat death of the universe, a state of maximum entropy in which no more usable energy exists to power stars, chemistry, or any physical process whatsoever. Modern calculations place this state roughly 10 to the 100th years in the future, long after the last stars burn out, the last black holes evaporate through Hawking radiation, and the last particle decays into featureless radiation, spread so thin across an infinitely expanding universe that no two particles will ever interact again. There is no specific moment of destruction to witness, no violent event, only an infinite, unbroken continuation of absolute stillness and cold forever, with nothing left capable of experiencing it, remembering it, or marking that it had ever been any different. Number 1. Physicists have calculated that the very fabric of empty space itself may be sitting in an unstable temporary state, and if it collapses into its true stable configuration, the destruction would spread at the speed of light with no warning whatsoever, meaning it could already be happening, right now, expanding toward us at this exact moment, and we would have no way of knowing until it arrived. In 1980, physicists Sidney Coleman and Frank DeLucia published a paper in Physical Review D formally describing vacuum decay, the theoretical possibility that our universe currently exists in a false vacuum state, a low-energy configuration that is stable enough to persist for billions of years, but not the true, lowest energy state physically possible. If a random quantum fluctuation anywhere in the universe ever triggers a transition to the true vacuum, a bubble of new physical law would begin expanding outward at the speed of light. In 2012, following the discovery of the Higgs boson at CERN, physicists including Joseph Licken at Fermilab calculated that the measured mass of the particle, approximately 125 billion electron volts, places our universe uncomfortably close to the boundary of this exact kind of instability. Because the bubble would expand at light speed, no signal, no light, and no possible warning could ever precede it. Every law of physics inside that bubble would be different, incompatible with atoms, chemistry, or anything resembling the universe we currently understand. A black hole destroys what falls into it, slowly, predictably, from a fixed location you can choose never to approach. Vacuum decay requires no approach at all. It could be a billion light years away, or it could already be crossing the distance between here and the edge of our galaxy, arriving with absolutely no announcement, ending everything, everywhere, simultaneously, before the light carrying the warning could ever have reached us in the first place. If you want to see more videos like this, click the video on screen now, and make sure to subscribe.